When we're working with circles, we know that the circumference is the distance around the outside edge of the circle. We know that to find circumference, we generally use one of two equations. We either solve circumference as pi times diameter, or we solve circumference as 2 times pi times the radius. Let's first explore and see how these equations work. We'll start by gathering data about the diameter and circumference of several circles and see if we can find a relationship to establish our equations. The diameter of the circle measures from one edge through the middle to the opposite edge of the circle. Taking our ruler, we can measure that distance. We see that on this circle, our diameter comes out to be 3 inches. If we try to measure the circumference though, we simply can't use the ruler because it's a curved edge and it can't really take the ruler around the curve. Instead, we're going to take a second copy of the same circle. We've put a different piece around the outside edge. We can take this piece off of our circle, straighten it out, and measure it. When I measure this piece, we can see that it measures to be about 9.5 inches. So the diameter of our circle is 3 inches, and it has a circumference of about 9.5 inches. We're going to go ahead and record this data on a table so that then we can compare it to the other circles. Moving on to our second circle, we're again going to measure its diameter and its circumference. However, instead of measuring in inches this time, we're going to measure in centimeters instead. We'll start by taking our ruler to measure its diameter. When we measure the diameter in centimeters, we see it has a diameter of 9 centimeters. Again, since the circumference is curved, I can't just take my ruler to measure it. So we'll take a copy of the same circle. This time, we have a piece along the outside edge that we can remove in order to measure the circumference. When I straighten it out along my ruler, we can see that this piece is going to measure about 28 centimeters. So this circle has a diameter of 9 centimeters and a circumference of 28 centimeters. We'll go ahead and record that data in our table so that we can compare it with our first circle as well. Let's go back to measuring inches and gather data from one more circle before we start to look for a pattern. On this small circle, we're going to start out by measuring its diameter. When I do, we see it has a diameter of exactly 1 inch. Then we will take the copy of it so that we can pick up the outside edge of the circumference and stretch it out to measure it. When I measure it out, we can see it has a circumference of a little over 3 inches. So we'll record that in our table. Our circle has a diameter of 1 inch and our circumference comes out to be a little over 3 inches. If we look at the data from all 3 of our circles, we can clearly see a pattern starting to emerge. On our last circle especially, we can see that circumference is about 3 times larger than the diameter. If we can compare that to the other 2, we see that is true also. The circumference is about 3 times larger than their diameter. That leads us to the beginning of equations. Circumference is about 3 times the diameter. Now generally we can't multiply with about 3, but we know a value that's worth about 3 and it's involved with circles, and that's pi. The decimal abbreviation we commonly use for pi is 3.14. So in our equation, we're going to change our about 3 to pi. So we have our first equation for finding the circumference of circles. Circumference is pi times the diameter. Now we have to find where our other equation comes from. Our other equation for finding circumference involves the radius. Well, I know that diameter is worth twice the radius. So instead of having diameter in my equation, we're going to substitute in 2 times the radius. Now, since multiplication is commutative, we know we can rearrange the order in which we multiply. So I'm going to arrange pi times 2 times radius into being 2 times pi times radius. Now I have my second equation for finding circumference. Circumference is 2 times pi times the radius. So no matter what circle we have, the relationship is always the same. The circumference is about 3 times larger than a circle's diameter. We're going to practice solving circumference using both our equations, pi times diameter and 2 times pi times the radius. Let's start with pi times diameter. To find my circumference, we're going to use 3.14 for pi, and we need to multiply that by our diameter. On our circle here, we see that 4 feet is our diameter because it goes from one edge through the middle to the opposite edge. So that means I'm going to be solving 3.14 times 4. When I do that, I get 12 and 56 hundredths. Since our diameter is measured in feet, that means our circumference also needs to be measured in feet. If both our equations are true, we should also get 12 and 56 hundredths when we use 2 times pi times the radius. To solve this one, I'm going to multiply 2 times 3.14 times my radius. Coming back over to my circle, I can see that 2 feet is my radius because it goes from the center to the outside edge of the circle, and its value is half that of the diameter. So I have 2 times 3.14 times 2. 2 times 3.14 is going to give me 6 and 28/100. I can then multiply 6 and 28/100 by 2, and that is also going to give me 12 and 56/100. Again, we're labeling our answer in feet. No matter which equation we use, pi times diameter or 2 times pi times my radius, we're going to get the same result for our circumference.